Here's another U-substitution problem. This is number 8, or example number 8, I should say. And if we look at this, we can see we have some constants, and it's always good to take the constants out. Now, there's kind of maybe a way we could use one of our formulas to make it take a shortcut, but it doesn't always work like that, so I'll just do this in a more general manner, and hopefully that will help. So what I'm going to do is I'm going to kind of rewrite this a little bit first, and I'll try to get at this constant because there's a square root of 2 times the square root of x. So I'll rewrite this as, I'll write it over here, equals the integral of 1 over, and then I could write this as 4 times the square root of 2 times the square root of x dx. And then we could take that out in front, so we could write that as 1 over 4 times the square root of 2 times the integral of 1 over the square root of x, and we could write that as x to the 1/2 dx. So that makes it a little bit easier to see, because then we could rewrite this as, when I say integral, I really mean antiderivative. Oops, forgot to put this out in front here. 1 over 4 times the square root of 2. And this would be x to the negative 1/2 dx. And then this is going to be 1 over 4 times the square root of 2. And then we could take the antiderivative of that just using our reverse power rule, or our u to the n plus 1 over n plus 1, but the u is just x, so it would be x to the n plus 1 over n plus 1. So if we add 1 to 1/2, we get 3/2. I'm sorry, negative 1/2. Excuse me. If we add 1 to negative 1/2, we get positive 1/2, and divided by positive 1/2. That doesn't look very good. Can maybe wipe that out a little bit. Oh, you can see that's positive 1/2. We'll fix it in just a second. Plus c. I should have taken the shortcut anyway, and that's the same thing as 1 over 4 times the square root of 2. And then times, and then we just put this up on top. So if you divide by 1/2, you multiply by 2. So 2 times x to the 1/2 plus c. And then 2 over 4 simplifies to be 1 over 2. So we have 1 over 2 times the square root of 2. And the square root of x is, I'm sorry, x to the 1/2 is the same thing as the square root of x plus c. So that's what you got. Okay. So the idea on this one, I think the main idea or the trick would be to try to get the constant out. And once you have that constant out, you've got something that's very doable here. And that's x to the 1/2 divided by 1/2. Okay? Or 2 times x to the 1/2 power, which is the same thing as the square root of x.